Hi viewers, you all welcome to ABKM Medics. In today's class, we're going to talk about equation of blood pressure. Blood pressure is the force of blood against the wall of the arteries. And this equation is the blood pressure equals to cardiac output times systemic vascular resistance. What is now cardiac output? Cardiac output is the amount of blood pumped by the heart per minute, which is equivalent to 4 to 5 liters per minute. For you to get your cardiac output, you have to times the stroke volume and the heart rate together. Now, what is stroke volume? Stroke volume is the amount of blood per contraction, meaning by the time hearts contract once, the amount of blood you get is known as stroke volume, which is equivalent to 50 to 100 mils. 50 to 100 mils times heart rate. Now, heart rate is the amount of heartbeats per minute, amount in which the heart beats per minute, which is equivalent to about 70 beats per minute. The moment you add or you times the heart rate, the stroke volume with heart rate, is going to give you your actual cardiac output. Then times systemic vascular resistance. By the time you add up or you times the cardiac output to systemic vascular resistance, it's going to actually give you your blood pressure. What is now systemic vascular resistance? Systemic vascular resistance is the pressure of blood within the blood vessels or resistance of blood within the blood vessels. Meanwhile, there are factors that will alter systemic or that can alter systemic vascular resistance. And these factors are three. One, we have the diameter of the blood vessels. The diameter of the blood vessels. Two, we have the length of the blood vessels. Three, we have the viscosity of the blood. Viscosity of the blood. Any moment there is narrowing of the blood vessels is going to increase the pressure of blood within the blood vessels. And anytime there is a widening of the blood vessels, it's going to decrease the pressure of the blood within the blood vessels. Then anytime there is increase in length of the blood vessels, it also increases the pressure of the blood within the blood vessels. And if there is decrease the length of the blood vessels, it's going to decrease the pressure of the blood within the blood vessels. Meanwhile, the viscosity, the thicker the blood, the pressure of blood within the blood vessels, and the thinner the blood, the pressure of the blood within the blood vessels tends to reduce. By the time you add the cardiac output times systemic vascular resistance together, it's going to give you your actual blood pressure. But today, we are not concerned on these two rather than the diameter of the blood vessels. And that is why, or that's what we discussed in our previous topics on short-term control of blood pressure, where we talk about the mechanism of baroreceptor, baroreflex. This is a situation where this time the heart, the cardiovascular centers or vasomotor centers in the brain is going to send a sympathetic message to that of the blood vessels to constrict the blood vessels using the pathway of these chemicals called adrenaline and non-adrenaline to narrow the blood vessels. And if the blood vessels are narrow, definitely there's going to be increase in blood pressure or increase in peripheral vascular resistance, which in turn increases blood pressure. Then in turn, this is where we, in case of antihypertensive drug like vasodilators, when you have these cases of increase in peripheral vascular resistance, or if there is vasoconstriction, here you administer drugs like vasodilators. What they do is to act on these blood vessels to widen the lumen of the blood vessels so as to decrease the blood pressure. This is how blood pressure is increased or decreased, and this is the formula. The cardiac output times stroke volume actually give you your blood pressure, the exact blood pressure you want. Then here there is these factors. When there are alters, they are going to increase the blood pressure, and they also may likely to decrease the blood pressure. What are they? Here we have the blood volume. Anywhere there is increase in blood volume, there is going to be increase in contractility of the heart. If there is increase in contractility of the heart, there will be increase in heart rate. If there is increase in heart rate, there is going to be increase in peripheral vascular resistance. In turn, blood pressure will be constricted, leading to peripheral vascular resistance. And if there is increase in peripheral vascular resistance, there are going to be shift in blood pressure. Then, a situation where you administer a drug such as vasodilator or class of antihypertensive drug, what they do is to widen the lumen of these blood vessels. After they widen the lumen of these blood vessels, it's going to bring about free movement of blood, and if there is free movement of blood, it's going to actually decrease the heart rate. If it decreases the heart rate, it's going to decrease the contractility of the heart and decrease the blood volume. And if the blood volume is decreased, there's going to decrease in blood pressure. And this is an equation for blood pressure.